Yes, welcome friends once again. Session 2 on block diagram algebra, that is from module 2 control engineering. So here let us understand once again the block diagram algebra, nothing but block diagram reduction method to get the transfer function, that is overall transfer function or control ratio. So how to get that one? So examples on reduction of block diagrams to obtain closed loop transfer function. So example number 1, reduce the block diagram into canonical form, nothing but simple form. So block diagram is given here, input is R, output is C. So you just move from left to right side, forward path. Two summing points are there, one after another. Then blocks are there, two blocks, G2 and G3. Another one is one takeoff point to the summing point, another takeoff point to the another next summing point. So in between one block is a G2, that is forward path G3. And so in this example we are having two forward paths and two feedback path with feedback signal H1 and H2, and regular path, that is G1, G4 and G2, and G3 is another forward path. So here the first step is combine all the cascade blocks using transformation 1. Cascade means the blocks in series. So here the block G1 with the transfer function G1 and G4 both are in series. You can combine the blocks according to the rule number 1 of block diagram algebra that we have discussed in the previous session, that is session number 1. So here you can combine, you can see here G1 and G2 turns into only one block with input and output, that is G1 and G4. The very first step we can do it. Cascading the blocks means combining the blocks in series. So these two blocks with transfer function G1 and G4, that you can combine it to make a single block with transfer function G1 and G4. That is very first step. So after that, combining all the parallel blocks using transformation 2. So here the parallel blocks G2 and G3, those are in a parallel blocks. You can combine it once again. So here you can see the block G2 and G3 in the same direction, forward path, and remove the loop and convert into only single block with the sign. Here the signs are both positive, so you can G2 plus G3. So in these two steps you can done reducing the block diagram by first step is cascading transformation 1, second one is combining the parallel blocks using transformation 2. Okay, now the block diagram looks like this. So eliminate the once again the minor feedback loops using transformation. Next transformation, that is G1 and G4, that you can see in the previous block. You have to combining G1 and G2, that is G1 and G4 with feedback H1 with positive sign, so that you can remove what is that G1 G4 with H1. So it turns into G of S, what is that one, G1 and G4 whole divided by 1 minus, why it is minus, it is positive signal, so 1 minus G of S into H of S. G of S is G1 and G4, H of S is H1. So this whole feedback signal turns into a simple block diagram with input output with transfer function, what is that, G1 G4 whole divided by 1 minus G1 G4 into H1. So once again repeat step 1 to 4 until the canonical form. To become as a canonical form has been achieved for the particular input. So here once again, so in this block diagram, so there are two feedback signals, one is here. So after removing that, combining the block with G2 and G3, these two blocks comes under once again series with the transfer function g1 g4 divided by 1 minus g1 g4 into h1 comes in with series or cascading with g2 plus g3, so that you can convert into like this, combining the block g1 g4 into g2 plus g3 whole divided by 1 minus g2 g4 into h1. So with feedback signal, that is h2 with negative sign, how to remove? Once again here g of s is g1 g4 into open the bracket g2 plus g3 whole divided by 1 minus g1 g4 into h1, that is feedback signal is once again h2. So how to, however in this example step 6 does not apply, so how to convert that one, that you can see here using this one, this you have to remove g1 g4 plus g2 g3 divided by 1 minus g1 g4 into h1. This is the feedback signal, that is h2 with minus this one. Okay, here this is output and this is input. How to get one? So here output is c of s, input is r of s, and this is g1 g4 g2 plus g3 whole divided by 1 minus g1 g4 into h1 whole divided by, this is looks like a g of s divided by 1 plus, why it is 1 plus? Here it is negative, 1 plus g of s is once again the same thing what written in the numerator, that is g1 g4 g2 g3 divided by 1 minus g1 g4 h1 into h of s, nothing but that is h2, that you can write here. So once again further you can simplify if possible, that is you multiply inside g1 g4 into g2, or you can keep as it is g1 g4 g3. So here in this example I will keep as it is. So here you can take LCM, that is 1 minus g1 g4 h1, here also 1 minus g1 g4 h1, both gets cancelled, here it's added 1 minus, what is that, here 1 minus g1 g4 into h1 plus g1 g4 into g2 g3 into h2. This is the transfer function for this example. So in the first example, how to decrease the block diagram using simple canonical form you have seen here by applying some of the rules, that is cascading rules. If the blocks are in series, how to remove it, and forward path, parallel paths, how to make into single path, that is g2 g3 g2 plus g3, and how to this one you have seen here in this simple example. Coming to the next example, so here what is that, once again same question, reduce the block diagram into canonical form with this example. So here this is the input r of s, this is c of s, so this is r of s, this is one summing point, this is one summing point, this is g1 g2 g3 g4, this is one summing point, second summing point, third summing point. So here from pickup point this is h2 with minus, from this pickup point h1 with plus, here from the same pickup point h3 with minus to this first summing point. So h1 h2 h3, these are the feedback signal with this negative sign, this is positive sign, once again this is negative sign. So how to decrease this one we will see. So once again, first to eliminate the loops g3 g4 g1, that is g3 g4 and g1, g3 g4 g1, we move h2, what is h1 h2, this h2 behind the block g4, this is g4 here, means this takeoff point you move here, what happens if moving the takeoff point ahead of the block, so this will affect signal, that is h2 into g4, so h2 by g4. If you shift the summing point ahead of the block, this is the block coming in between, this content you have to divide to this signal, so that is shown here. h2 by g4. Now takeoff point comes here. So why you have to shift like this? If you shift like this, these two blocks comes in series. You can combine it. Then you remove one by one. This is one loop. Remove this loop, combining with this one. Next remove this loop. Then combining with g1. Then finally remove this one. You will get the transfer function. So here the shifting of takeoff point is very much required. If you not shifting this takeoff point this side, it is not possible to solve the example. So as far as avoid shifting a summing point toward the another summing point, or shifting of yes takeoff point toward the summing point. So always you can shift the takeoff point toward the takeoff point, but don't shift this towards another summing point. Okay. So here eliminating this one, g3, g4, g1. So now we can g3, g4, we can solve it. So the transfer function is this one, that you can see g2, g3, that is g3 and g4 both are in series, and remove this feedback h1. This is g of s, this is g of s, g3 and g4, this is h of s. So g of s divided by 1 minus, why it is minus, this is plus here. So 1 minus g of s, this is g3, g4 into h1, that you can see here. g3, g4, 1 minus g3, g4 into h1. Okay. So now this is combined with this. Now it is both the blocks are in series once again. You can, it is called cascading. So you can, these two blocks you can yes gets added, means multiply. That is, then eliminate the inner loop containing h2 by g4. So now here, so after combining these two, you can remove this loop. It is once again negative feedback loop. So this is now g of s, that is g1, g2, g3, g4 divided by 1 minus g3, g4, h1. This is the h of s, sorry, g of s. So now it is g of s and this is h of s with negative sign. So once again here g of s is g2, g3, g4 divided by 1 minus g3, so this as it is, into h of s, that is h2 by g4, that cancels. Finally it becomes like this, that is g2, g3, g4, 1 minus g3, g4, h1, g2, g3, h2. Okay. So once again here, after removing this loop, it will become like this, combining with this series g1. So here that you combine it once again, it is shown here. Once again you multiply g1, g2, g3, g4, and with this negative loop h3, that you can remove it. Okay. Finally reduce the loop containing h3, this one, that we have to remove it. Okay. So once again here, this is g of s, this is h of s with negative, g of s divided by 1 plus, because it comes minus here, plus into minus minus, and g of s into h of s h3. So we will get, this is the transfer function. So that is, what is that? g1, g2, g3 divided by 1 minus g3, g4, h1 plus g2, g3, h2 plus g1, g2, g3, g4 into h1. This is the y of s and this is the r of s. You can finally write y of s divided by r of s, that is output by input. Some of the example here taken as c of s divided by r of s. This is the transfer function, that is overall transfer function or control ratio for this example. So I hope these two simple examples we understand how to decrease the block diagram into simple form. So these two examples we have studied in this session, decreasing the block diagram into canonical form to get the overall transfer function. This one example, this is another example. So with this I conclude my second session.